Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience, who would be curating the RealSci_Nano Twitter account.
Hi everyone. Today we have with us Ahmad Kirmani, who is a postdoctoral researcher at the National Renewable Energy Laboratory in Colorado, USA. Hi Ahmad, how are you?
Hi Pranati, nice to see you. I'm
nice
good,
to
thanks.
See you. Excellent. Let's take a deeper dive into getting to know you as a scientist and your science as well. So let's start by understanding your career journey so far. So please tell us about your scientific career.
All right, thanks. So yeah, I did my undergrad in physics from Aligarh Muslim University in India. It's a university in the north of India. And I majored in condensed matter physics. And then I basically moved to my PhD for my PhD into the King Abdullah University of Science and Technology. That was a new university at that time. It's in Saudi Arabia, and I joined KAUST in 2011. I was part of the sort of the first cohort of grad students at that time in my research group, and so gained, I would say, valuable experience of building a research lab, facing challenges of what one can imagine in a laboratory that does not really exist before you join, and so that really equips you with invaluable experience, I would say. And then another thing that I realized was I was coming from a background of physics and basically transitioning into material science. That was very, I would say, industrial in its nature, or trying to solve problems that are that can be marketable one day. So that was I felt initially it was an abrupt transition for me, going from physics to material science. But then it had its own challenges and I had my learning curve. But what I found was the positive that came out of it was really working at the interface of physics and chemistry over the years of my PhD, and trying to develop a deeper understanding from physics-based understanding of this industry-oriented field that is solution deposited electronics. And that, I think, again, that was this working on the interface thing that happened for me or doing my PhD, and that really helped. This eventually, I would say, resulted in one of the first industry compatible fabrication of the solar cells that I was working on. I was working on nanocrystal based solar cells, quantum dots, as we call it. After my PhD in 2017, I moved to the US to join as a guest researcher in the National Institute of Standards and Technology, NIST. It's a national lab in the Maryland area. I basically, again, here opted for a slight change in my research path. And that change was trying to focus on fundamentals again, trying to highlight microstructure, how, let's say, crystals grow, right? What happens at the boundaries? Can we have better control over crystal growth? And can that then define the properties of these materials, of the devices? And so that became my focus for a couple of years when I was at NIST and trying to address questions on structured transport and thin film electronics. Having gained that understanding, I would say I moved on to the more sort of flashier or superstar of the next generation photovoltaics, the perovskites. And perovskites are ink-based, ink-deposited materials. And you start with very low cost ink and deposited using a very low cost deposition technique, such as spray coating or blade coating, right? It's literally painting. And then what you have eventually is a device that can revolutionize the sectors of energy and electronics as we know it. So, and that's what I did when I joined National Renewable Energy Laboratory in US here. I've been doing that for a good couple of years now, and it's been very exciting, I would say. It's my first time in stepping my feet into perovskite, so it's been a steep learning curve. But I think I've defined a niche here with trying to understand radiation matter interactions in perovskite photovoltaics. And this is geared toward taking this technology beyond Earth and into space.
Ooh, wow. Okay, so from condensed matter physicists to now taking perovskites or nanomaterials to space and technology to space, that's quite a journey you've had. This is really
Yeah.
inspiring, really cool. Thank you for sharing that with us. Now, my next curiosity about your science is about your current research, and you already briefly touched upon that you're working on perovskite-based solar cells. Where does this fit in this big picture, your current research? Where does it fit in this big picture of materials or nanoscience? Because it's quite a broad topic.
Right. So physics, chemistry, and material science. I think that's sort of the three-phase boundary, I would say, if I'm to use that word. That sort of defines what I'm doing right now, trying to understand these radiation matter interactions in perovskites, as I mentioned, from a physics understanding. So this has interestingly brought nuclear physics into the picture. And it's funny because I spent a couple of months back in my undergrad when I was in India in the Indian Space Research Organization, ISRO, to understand the magnetic field in the Earth's magnetosphere and that sort of stuff. And I absolutely had no idea that I'm going to be revisiting this 12 or so years later. And here I am basically trying to, again, look at magnetosphere of Earth and what protons and electrons exist there and can damage perovskite solar cells once hopefully we launch them. We actually did a launch recently in collaboration with NASA. So we sent our perovskite solar cells to the International Space Station. We are going to hopefully get them back in 6 months, and we'll then characterize them to study how space affects perovskites. But yeah, that I would say is how my research fits into the material science category. My PhD was very much focused, I would say, on nanoscience, as in I was exploring nanocrystal-based solar cells, or colloidal quantum dots, as we call them. That's the nanos version of single crystals. So they are crystals at the nanoscale. I would say I've zoomed out now and have been working on bulk perovskites, which is having its own challenges. And so I've been loving this.
Okay. All right. That sounds really cool. Sending perovskites to space. I mean, that is like, and bringing them back from space and then studying them and seeing how they've changed in that environment. That is really, really cool. So Ahmed, it sounds to me that so far you have been involved with in a lot of interesting research projects, a lot of exciting and super interesting research projects, be it during your bachelor's, be it during your PhD or your first postdoc or now your second postdoc. Now, this question is difficult, I know, before asking it, but if you have to pick one research project that you're most proud of, or the most fun or quirky one, could you pick one and explain it to us in super simple words, please?
Right. So what comes to my mind is basically one of the things I explored or demonstrated in my PhD, and that I typically call my highlight of my career. But then there was sort of an extension of that, I would say, in my postdoc at NIST with a different material system, but a similar challenge. And this deals with, again, the lab to fab transition, right? So a lot of these devices, this whole sort of research theme of ink-based deposition, right? That is in stark contrast with these technologies in the 1980s or 90s, where single crystals, for example, would be grown on a larger scale, lots of high temperature annealing involved, lots of costs involved, and very careful handling of them so you don't introduce defects. Whereas here, we are literally making salts, dissolving salts in solvents, making ink and inks, and then depositing them, right? So one thing that is the way to start typically, right, when one wants to explore these material systems is to obviously do it in the laboratory using techniques that are not scalable, that are costly, and you would not imagine using them in the industry, for example. Mm-hmm. So there's that transition one has to do at some point, trying to think about beyond lab scale and into the market scale. That is a scale up. right? And it brings with it obviously its challenges. So the thing that I did, I would say that I'm most proud of, is to understand how to take the lessons, or maybe relearn the lessons that you establish in the lab scale with an unscalable technology to the market scale using a scalable technology, and trying to then obviously understand how the films grow, and how to efficiently grow them to not compromise their performance, and to essentially hit performance parity between lab scale and the lower cost market scale. I did that in 2018 with nanocrystal based solar cells, and then again in 2020 with a different technology. It's called metal oxides, and this is basically a technology that's similar to being used, what's used in iPad Air 2 series, where they use that for the backplane. It's a metal oxide transistor that powers the high resolution displays that we see. But then obviously it's all done using vacuum deposition, and the new thrust is to explore that using coating techniques. And I would say we were one of the first to basically explore that and show performance parity. So that's sort of the exciting part of the projects, or the projects I would say that I'm most proud of in my career so far.
Yeah, let's say one of the most proud of, because I'm pretty sure you're proud of most of your research projects. And I can imagine why you picked this one or these ones to be the projects that you're, let's say, a little bit more proud than the rest. I can totally understand that, because that does sound really, really cool.
Thanks.
Ahmad, it's clear to me that you love the research aspect of being a scientist. But as a postdoc now in the US, being a scientist, there are other facets to your work as well, other than just doing the research. So what else do you like about being a scientist?
Building networks. Being a scientist has allowed me to build networks, going to conferences, and obviously the lesson that we all have learned, I would say, over the last 18 years and counting, is to basically build virtual networks. The importance of Zooming, right? Importance of Teams, all that kind of stuff. To build networks, to communicate what you have in your mind, to write papers, basically, to let that thing that we think can change the world be on paper and be read by your colleagues, and hopefully then it's sort of a pyramid. Then it can be read by those who are important, and are important in the sense of making policies, right? The policymakers. And if what you have in your mind can be read, let's say, by policymakers, I think that really brings about a big change that opens the door to the dream of scientists. So it's this liberty, it's this freedom, I would say, of communicating, of building networks that really inspires me and makes me really excited about what I'm doing. But also, I would say in general, being part of a global community that shares the concerns that ail us right now. For example, climate change. That's sort of the biggest problem, obviously, and unfortunately, it's going to become even more severe as we head into the next decade. So yeah, and then being part of this whole community that has the same concern, that shares this concern with you, and then everybody sort of aligns to bring positive change. That is, I think, the biggest sort of the fruit that you get of being a scientist.
Yeah, absolutely. Yeah, absolutely. I understand. I understand what you mean. And I also relate to it to a certain extent. So building networks, communicating, making a big impact, and also with concerns that need to be addressed on a global level, on a global community level.
Right.
I'm very happy that we have people like you who are active researchers, who are part of the research community, who think like that, who think about these things as well, and not just the niche field that you're working in. So that's really, really nice for me to know. Ahmed, next question for you is, what advice would you give yourself if you were to go back in time, or to folks who are starting out today on their scientific journey? Do you have some advice?
Yeah, I think the most important advice, and that has really shaped me to a researcher over the last several years, is to not be afraid and to be willing to work at interfaces of different fields. And I would actually say that interface is the discovery. That's exactly where the discovery is waiting to happen. changing your research field will definitely challenge you, would put you in a position that you don't want to be in. That will be a learning curve, a steep learning curve, and you don't really have that much time in your career to learn. You don't have a lot of time. For example, when you're transitioning out of your PhD and into a postdoc career, you don't have a lot of time to learn things. You want to literally hit the ground running. But that's exactly where the discovery is waiting to happen. By constantly living at the edge, you will discover your edge.
Mm-hmm. Oh, that's a good line. Yeah. Stepping out of your comfort zone and challenging yourself. That's very, very important.
Yep.
Really, really cool advice. Thank you, Ahmed, for that. I hope your research experience has been wonderful so far and will continue to be wonderful in the future as well. However, we all have wishes to improve our work. So, if you have 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here, okay?
Right. So a couple of things that come to mind, and when I think about my career and like what I might have maybe done a bit differently, would have been maybe giving more conference talks, communicating more. I did have the being part of KAUST. I would say I had the benefit or advantage of visiting different cultures and giving talks in different countries. But like also maybe one always thinks back and be like, maybe did I do it less? Was there more opportunities to do more? But also, I think this also comes from what has happened over the last 18 years because of COVID, right? We just have been stuck in our comfort zones, I would say, or the barrier to get out has obviously gone up. And so giving more conference talks, communicating more, being more involved in science communication, I would say. SciComm is such a buzz these days, and importantly so, right? We need to educate the next generation about climate change, about what the next generation is headed toward, right? And so I think that just makes, I would say, this is sort of a concern that a lot of people can relate, and share with me this concern that science communication is so much more needed. And I would say this platform, like Real Science Nano, is one of is a good example of that, basically, right? Trying to communicate what nano is, and for example, what nano can do to address these these challenges, climate change. So yeah, I wish these existed before as well. And I think I would say also, when you're working in a research field that is very industrial, I would recommend or suggest folks to think about also patenting your research findings. When we are routed toward academia, we don't really, I think patenting sort of takes a backseat. But if I think about my research findings, I did have a couple of results, I would say, that I hold pretty close to me, my heart, and I appreciate that. Or like, I like those as sort of the highlights of my career. I wish I had patented them. So yeah, those are a couple of things that I wish I had done, but I maybe did not have the chance to do that.
Okay, well, all 3 very practical wishes: more conference talks, more science communication, and patenting your discoveries. And I feel like more confidence talks, the number of talks that you will be giving at conferences will only grow. And the second wish you have to be more involved with science communication, well, being a guest on our Real Scientist Nano and our podcast series, you're already working in that direction.
Yeah, thanks for the opportunity.
We are happy to have you. And the third thing about patenting the research findings, well, if you haven't done it in the past, you can start doing it now. So very realistic wishes. I should have said that, yes, I'm promising that all your wishes come true before you answered the question. But you're already making sure that that is happening. So Ahmad, this has been wonderful getting to know you as a scientist and your research as well. Before I let you go, one last question I have for you. We are living through very interesting times, which seem to be getting better at times and seem to be getting worse at times. Of course, I'm talking about the COVID pandemic. What are your learnings from the year 2020 or the pandemic as a whole of 18 months or more than 18 months that it keeps dragging on and on and on?
Right. I feel like we have been sort of riding a sinusoidal curve, and as soon as a minima hits, as soon as you find yourself in a minima, I would say wrap up your old papers. That's a sort of the advice also I would want to give it to postdocs and grad students. That's what I did in 2020. That's sort of one key learning from me the last year. I was able to get some of the old unpublished work from my PhD to get published into a few papers, and yeah, don't try to delay publishing old papers. New ones quickly start taking higher priority, and the old ones actually, are forgotten. I would also say that use such times to learn new skills. For example, one thing that I invested my time in was basically trying to use science illustration softwares, and that led to a bunch of front cover illustrations. And I'll definitely be talking about that more on the next week on Real Science Nano's Twitter account.
All right, wonderful. Thank you for sharing your learnings and your advices as well. Looking forward to having you on Real Scientist Nano and knowing more about how you send perovskites to the International Space Station. And also already looking forward to having you back in 6 months' time when you have the perovskites back from the ISS and you're characterizing it. So thank you very much. And as I said, looking forward to having you on Real Scientist Nano.
Thank you so much, Pranoti, for having me, and it was fun chatting with you. And I look forward to curating the account next week and sharing my experiences and having fun with the Nano community.
Thank you for listening. To know more about us, please visit our website, realscientistsnano.org, and follow us on Twitter at realsci_nano.